Alright, we are doing additional example set number 5. Number 1. Graph the function given here, a quadratic function. So let's write the function down again. F of x equals x squared minus 6x plus 5. So I see it's a quadratic function. So I have a few steps I should go through. The first step is finding out if the parabola is pointing up or down. So let's make a little dot for the first thing. The value of a is a 1, which is positive, which means the parabola is pointing up. So I'm going to have that shape. Then what is the next thing that I look at? I have to figure out where this minimum point is going to be. So I have to find the axis of symmetry. That is at, or when, x equals negative b over 2a, which in this case b is negative 6. So it's going to be negative 6 over 2 times 1. So x is equal to 6 over 2, which is 3. So let's see here. Let's get a graph going, and we update it as we get more information. So when x is equal to 3, I know the axis of symmetry lies over here. And I also know the shape. So let's now find the minimum function value. That's going to be when x is equal to 3. The function value, let's see where does it sit on this line. So I get 3 squared minus 6 times 3 plus 5. No need to worry too much about that. I can just do that completely from scratch if I want to. I get negative 4. So let's suppose negative 4 sits over here. So there is my minimum function value. Now I want to draw my parabola. Do I pass it over here or to the right of the origin? Well, this 5 is my y-intercept. So I know it's going to go through a point up here, and I can sketch my parabola something like this. It doesn't have to be perfect in any way. You just get the idea across. Let's suppose something like this, and then that you just mark off as a 5. The scale doesn't have to be perfect or anything like that. And if the question doesn't specifically ask for the x-intercepts, I'm not really going to bother with them because they are more work, but you can easily just set this equal to 0 and find the x-intercepts. Next one is number 2, graph the function given here. Again, a quadratic function. Number 2, let's write the function again. Negative 2x squared minus 6x. Clearly a quadratic function. First thing that I want to do is look at the value of a, which is now negative 2, which is less than 0. So that means that I'm going to have a parabola pointing down, and I'll have a maximum value. What x value? Where does that sit on my graph? Well, for that I need to find the axis of symmetry, and that is when x is equal to negative b over 2a. So x is then, well, that is b, negative 6. So negative 6 over 2 times negative 2. So x is equal to 6 over negative 4. So you can simplify this in many ways. You can say it's negative 3 over 2 or negative 1.5. Doesn't really matter. So let's get a graph going here to see where I'm at with this parabola and update it as we go. So I'm sitting over here at negative 1.5, and that's where my axis of symmetry is. Now I want to find out, where do I sit on this line? Where does my maximum value, my maximum point sit on this line? So I want to find the maximum function value, and that is when x is equal to negative 1.5. So I plug that in, and let the calculator do the rest. So I have a negative 2 times 1.5 squared, since the negative is going to square out. I can also combine these two negatives to make a positive. 6 times 1.5 just makes my expression a little simpler, and I get 4.5. So it sits reasonably high. Let's put it over here. 4.5. Now my parabola I can sketch, but where is the y-intercept? The y-intercept is 0 in this case. So I know it goes through here, so I can sketch my parabola accordingly. Let's see if I can get it through there. That's good enough, something like this. As long as you have some bend to it, it's not a pointy, it doesn't make a pointy shape up here, something like that. That is more than sufficient. For number 3, the demand function for a manufacturer's product is P equals 100 minus 10Q, where P is the price per unit and when Q units are demanded per day. Find the level of production that maximizes the manufacturer's total revenue and determine this revenue. Alright, so let's start by writing number 3. What do I have? I have P equals 100 minus 10Q. They're friendly enough to define the variables for me, so I don't have to worry about that. Now revenue, let's call it R, is P times Q. So I can replace this expression for P. So I have 100 minus 10Q times Q. So I get R as a function of Q is negative 10Q squared plus 100Q. I like the square term first. So now I have my quadratic function here, and I can look at this and see what's happening. What is the value of A? Negative 10, which is negative, which implies that I have a parabola pointing down, and I'll have a maximum value. Where does that maximum occur? At the axis of symmetry. That is when Q is now my variable instead of an X, when Q is negative B over 2A. So that means, what is B here? B is 100. And A is negative 10. So I get 100 over 20. So Q is equal to 5. So the last thing that I want to do is, I've identified that I do have a maximum. What is that maximum revenue value? That is when Q is equal to 5. So I plug in a 5 for Q, and I see what the answer is. So negative 10 times 5 squared is 25, plus 5 times 100 is 500. And I get 250. So I can write a little concluding sentence. The maximum revenue of $250 is obtained at 5 units. Let's do number 4. The demand function for a manufacturer's product is P plus 4Q equals 1,000, where P is the price per unit when Q units are demanded per week. Find the level of production that maximizes the manufacturer's total revenue and determine this revenue. So let's write down what our demand function is for number 4. They give it to me in a less than ideal form, so I will write that as P equals, that doesn't really matter, 1,000 minus 4Q. Now my revenue, let's call it R, is P times Q. So P is the same as this, so I can replace that, and I have this calculation. So R as a function of Q is negative 4Q squared plus 1,000Q. So now I have my quadratic function for the revenue. I need to analyze this function a little bit by looking at A, which is negative 4, negative, implying that I do have a parabola pointing down, so I will have a maximum value. Where is that maximum value? What value of Q? For that I need to look at the axis of symmetry. That is when Q is negative B over 2A. So Q is, well, B is 1,000 over 2 times A, which is negative 4. Let's go over here. So Q is equal to 1,000 over 8, which is 125. Now what is that maximum value corresponding to Q equal to 125? The maximum revenue value, maximum function value, is then R evaluated at 125. Put it in for Q. And the calculator says negative 4 times 125 squared plus 1,000 times 125, and I get 62,500. Now just a little concluding sentence to wrap things up. The maximum revenue of 62,500 is obtained at 125 units. For number 5, I want to solve the system of equations given here. So let me just rewrite that. For number 5, I have x plus 4y equals 3, and I have 3x minus 2y equals negative 5. So there are multiple ways to do this. For the sake of consistency, I'm just going to do one way that always works, but I do have the downside that I might create some fractions, but that's okay. So I'm going to rewrite this guy into my y equals mx plus b form as, let's do an in-between step, 4y equals negative x plus 3. So then y equals negative 1 over 4x plus 3 over 4. The next one I'll do 2y equals 3x plus 5. Let me just double check that. I move the 2y over here, that one over there. then y equals 3 over 2x plus 5 over 2. So now the solution is, I set them equal to each other. So let's say here's the solution of my system. I get when I set these two equal to each other, so negative 1 over 4x plus 3 over 4 equals 3 over 2x plus 5 over 2. So now I do have some slightly unpleasant fractions, not the worst fractions in the world, but they are fractions nonetheless. I can make this look much better if I just multiply throughout by 4 to get negative x plus 3 equals 6x plus 10. Now let's take the x to that side to get 7x, the 10 to the other side to get negative 7, so x is negative 1. So that's half of my solution. I want to find the other half, so let's number this 1 and 2. You can use either one, whichever one you like, to be honest. I'll use number 1. From 1 we get y equals negative 1 over 4 times negative 1 plus 3 over 4. So that's 1/4 plus another 1, so y equals 1. So I have my solution there. For number 7, supply and demand equations for a certain product are given here, where P represents the price per unit in dollars and Q represents the number of units sold per time period. Find the equilibrium price and quantity. Just another way of asking, solve the system. So I have 180p plus Q equals 2160, and my other equation is 300p minus Q equals 2400. Now I can write that as P equals MQ plus B, or I can write it as by solving for Q, and that's going to be a much simpler looking equation with no fractions. So I'm going to do that in this case. So Q is simply negative 180p plus 2160. And in the second one, Q is 300p minus 2400. Let's call that number 1 and number 2. So now the solution is when I set them equal to each other. So the method is the same. 300p for the next one minus 2400. So now I could take the 180 to the other side to get 480p, and the 2400 to this side. 2160 plus 2400 is going to be 4560. So P is 4560 divided by 480, and I get 9.5. What is the corresponding value for Q? You can use either one of these. Let's use 1. Q is negative 180 times 9.5 plus 2160. Q is negative 180 times 9.5 plus 2160. I get 450. So the equilibrium price is $9.50, and the equilibrium quantity is 450 units. Next, they want to know, find the equilibrium price when the demand quantity increases by 10%. So now I have to identify this. I'm not going to look at this respectively. I'm going to identify for myself which one is supply and which one is demand. Let's start that on a new page. And number it 7b. So I had 180p plus Q equals 2160, and the other one was 300p minus Q equals 2400. Now if I do write them in the P equals MQ plus B form, I can easily identify which one is demand and which one is supply. So I will write an in-between step just for safety before dividing by the coefficient of P, and then I can say P is equal to negative 1 over 180Q plus, what's 2160 divided by 180? It's 12. That's nice. The next one is 300P equals Q plus 2400, and that then becomes 1 over 300Q plus 2400 over 300 is 24 over 3, which is 8. So now I can see here, well, the demand curve is going to be this one because the slope is like this. Supply curve is going to be this one because the slope is positive. So that's demand and that's supply. So now they say that the demand quantity increases by 10%. So I did this to identify which one is which. Which one am I looking for? I'm looking at this one. The demand quantity increases by 10%. So now I'll go back to my previous versions and look at the quantity side of things by writing it as I did previously. Negative 180p plus 2160, and Q equals 300p, moving that side, this side, minus 2400, the same as what we had before. So this is, the first one is demand, and this is supply. And previously we set them equal to each other where the demand quantity equals the supply quantity. But now this stays the same. The demand quantity increases by 10% to give me Q equals 1.1 times negative 180p plus 2160. It's an increase of 10%. So now I set these equal to each other. Now the new equilibrium is when these two are equal to each other. The new increased demand quantity compared to the current supply quantity. So I have 1.1 times negative 180p plus 2160 equal to 300p minus 2400. Now let's see, 180 times 1.1 is 198. 2160 times 1.1 is 2376. Still the same right hand side. Now I want to put all the p's together, so take this one to the other side to get 498p, and this one to this side. 2376 plus 2400 is 47.76. So P is equal to 47.76 divided by 498, and I get 9.59, close to 9.59. Let's use that. To find the corresponding value of Q. It doesn't matter which one I use. Let's call this one again now 1 and 2. It doesn't matter. 2 might be the simplest one because it didn't really change. From 2 I get the corresponding value is 300 times 9.59 minus 2400. Q is 300 times, whoops, where did I store that guy? I don't know. I guess we have to calculate the previous one again. 4776 divided by 498. I just want to store that to use the precise value. So now I can use 300 times that exact answer minus 2400, and I'll get 477.111.108. It's close enough. So this is the new solution to my system. Equilibrium price increased from $9.50 to $9.59. Equilibrium quantity increased as well to 477 to meet the higher demand. So what happens is when I look at my demand curve and the supply, it was sitting at 450 and $9.50. Now the demand increased by 10%. Now we saw last time it's not a shift of this line to a parallel line, but it does flatten out. We saw that in class. In any case, it does move to a higher quantity and a higher price. The question is, where does it stabilize now? In number 8, the Bigfoot Sandal Company manufactures sandals for which the material cost is 85 cents per pair and the labor cost is 96 cents per pair. Additional variable costs amount to 32 cents per pair. Fixed costs are 70,500. If each pair sells for $2.63, how many pairs must be sold for the company to break even? Alright. So a lot of information is given there. So let's just extract it from the paragraph and see what we have to work with. So they manufacture sandals for which the material cost, so let's say here, material cost is 0.85 per pair, and the labor cost is 96 cents per pair. I have additional variable costs of 32 cents per pair, fixed cost of 70,500, and selling price is $2.63 per pair. So now let's say let Q represent the number of pairs that should be sold. Since, how do I look at this? I have profit equals revenue minus total cost. Since profit equals revenue minus total cost, what is the revenue in this case? Well, I make $2.63 per pair. What is the total cost in this case? I don't have just this as a single variable cost. I have all of these. So I have 0.85 plus 0.96 plus 0.32 as my actual variable cost, plus the 70,500 as my fixed cost. Break-even point is when the profit is 0. So I have the following equation: 2.63Q minus this, what is that? 0.85 plus 0.96 plus 0.32, 2.13. So revenue minus variable cost plus fixed cost equals 0. So I have 2.63Q minus 2.13Q minus 70,500 equals 0. 2.63 minus 2.13, 63 minus 13 is 50. 70,500. So Q equals 70,500 divided by 0.5, 141,000. So 141,000 pairs must be sold to break even. For number 9, the market equilibrium point for a product occurs when 13,500 units are produced at a price of $4.50 per unit. The producer will supply no units at $1, and the consumers will demand no units at $20. Find the supply and demand equations if they are both linear. So in number 9, I am going to define my P and Q variable. Let P represent the price and Q represent the quantity, same as before. Now I'm going to have a demand equation of P equals, I'm going to not say MQ plus B, but I'm just going to number this M1 and B1, because I'm also going to have a supply equation. P equals MQ plus B, and I want to distinguish between the two. So the supply I'll number as 2, M2 and B2. And these equations will be different, so I can't use an M for both. There's only, they don't have the same slope necessarily. Well, they definitely don't have the same slope. Now let's see the information that is given. For this one, we have that demand no units at $20. So when P is 20, Q is 0. For this one, we have that they supply no units at $1. So when P is 1, Q is 0. So this means that B1 is 20, because that's when Q is equal to 0. And this means that B2 is 1. So I update. Here I get P equals M1Q plus 20. And for supply, I get P equals M2Q plus 1. Now for both, they give me the information that I have 13,500 units at a price of $4.50. So when P is 4.5, Q is 13,500. So I can plug that in and get the value of M in each case. In this case, let's plug it in. So 4.5 equals M1 times 13,500 plus 20. In this case, 4.5 equals M2 times 13,500 plus 1. So this one's solving for M1, I get 13,500 M1 equals 4.5 minus 20 is what? Well, if you're not sure, let's use a calculator and see. 4.5 minus 20. You don't want to guess and guess wrong. Negative 15.5. So M1 is then negative 15.5 divided by 13,500. And I get negative 0.001148. Let's use 4 decimal places. For this one, I get 13,500. M2 equals 3.5. So M2 equals 3.5 divided by 13,500. 0.000259. I'll round it to 3. 25 rounds to a 3. You could have also represented the quantity in terms in thousands, and your M would be a nicer number, but it doesn't matter. I think most people don't think to do that, so let's do it like this. It doesn't matter, it's all the same. So now my demand equation is P equals negative 0.001148. You can also use a fraction if you want, doesn't matter, plus 20. My supply equation is P equals 0.00025993Q plus 1.